How Vikings built stormproof houses without nails, and they still stand. Imagine standing on the raw, exposed coast of Norway or the volcanic plains of Iceland 1,000 years ago. It is midwinter. The sun hangs low, barely a smear of light on the horizon, and from the North Atlantic a storm approaches, one so violent it can peel rocks from cliffs and rip entire forests out by the roots. The wind doesn't blow, it screams, clawing at the earth at more than 120 kilometers per hour. Today, storms like that twist steel beams and crack concrete. Rigid structures fail. Yet in this ancient, frozen landscape, something impossible stands firm. A house. No cement foundation, no steel frame, and not a single iron nail. When the gale hits, the house doesn't fight. It bends, it groans, it shifts, and somehow it survives. Welcome back to Historia Prime. Today, the Vikings are not warriors, but engineers, builders who mastered storms long before modern science. How did people with simple hand tools create homes that still stand after centuries? How did they waterproof wood without chemicals? And why are modern architects now studying their forgotten designs for the future of sustainable housing? From living nails that tighten with moisture to curved walls shaped like wings to cheat the wind, we are about to open the blueprint of the Viking longhouse. Whether you love history, survival skills, or simply a good mystery, what you're about to learn may change how you look at your own home. So take a breath, brace yourself, and step with me into the storm. Part 1. The Philosophy of the Bend. To understand how a Viking house survives, we first have to unlearn nearly everything we think we know about building. Modern construction is built on defiance. We pour concrete, we weld steel, and we declare almost arrogantly, "This wall will not move." But the Vikings lived in a world where anything that tried to stand rigid against the North Atlantic eventually snapped. They watched nature more closely than we ever have. They saw ancient pines bow in the gale, yet remain rooted. They saw their ships, thin wooden hulls, flex and twist over waves that would swallow a house whole. They learned, quietly and without theory, a truth that modern engineers often forget. Survival doesn't belong to what resists the storm, but to what yields to it. This philosophy became the soul of the Viking longhouse, the Longhouse. These structures were not crude huts assembled by desperate farmers. They were deliberate, elegant machines of survival. Some halls, like the great chieftain's hall uncovered at Borg in Norway, stretched more than 80 meters in length, an architectural feat on par with a modern aircraft hangar. And still, their guiding principle remained beautifully simple. Flexibility is strength. Yet the Vikings also understood that flexibility alone could not save a house. You could build the most graceful structure in the world, but if the earth beneath it betrayed you, the entire home would rot, sink, or tear itself apart. And so, before they shaped their bowed walls or engineered their bending beams, they confronted the most silent killer of all. It wasn't the wind, it wasn't the snow, it was the ground itself. And solving that problem would unlock everything that came after. Part 2. The War Against Rot. The Foundation. If you've ever built a shed, a fence, or even left a wooden board outside for too long, you already know the villain of this story: rot. In the wet, salt-heavy soils of Scandinavia and the North Atlantic, rot isn't slow. It's ruthless. Wood touching the earth behaves like a thirsty straw, pulling moisture upward. Fungi follow that moisture, and before long, the entire structure begins to melt from the bottom up. So the question becomes unavoidable. How did the Vikings, without concrete, without rebar, without modern preservatives, keep their homes alive on some of the harshest, wettest ground in the world? They turned to a deceptively simple but brilliant solution known as the dry stone foundation. Archaeological sites stretching from Lance O Meadows in Canada to the ancient farmstead of Sturng in Iceland reveal the same quiet genius. The Vikings didn't bury their beams in wet soil. They didn't pour mortar. Instead, they gathered flat, dense stones, granite, basalt, limestone, and stacked them carefully, almost surgically, under the massive sill beams that formed the shoes of the house. No glue, no cement, just gravity, friction, and physics. By lifting the beams only a few inches above the earth, they severed the moisture highway. Water couldn't wick upward, and fungal rot lost its doorway. Yet the brilliance goes deeper. Because the stones weren't locked in mortar, the entire foundation could breathe. Air flowed underneath the timber, keeping it dry. And when winter freeze-thaw cycles made the ground heave and buckle, these loose stones shifted with the earth instead of cracking. The house didn't fight the ground. It rode it, like a raft floating on frozen soil. Around the perimeter, the Vikings made another strategic move. They carved shallow trenches and filled them with crushed, angular gravel. This wasn't decoration. It was drainage engineering. The gravel created pockets of empty space where water could disappear instantly instead of pooling under the home. And at places like Hofstadr, archaeologists found something even more unexpected mixed into the floors: iron slag and hammer scale from the blacksmith's forge. What looked like trash was actually purposeful. These metals compacted the soil, hardened it, and may have even added antimicrobial defenses against mold. So the first lesson from the Viking longhouse is surprisingly modern. If you want a structure to survive storms, centuries, or simply a long rainy season, you must respect the ground beneath it. Keep your feet dry, let your foundation breathe, and never underestimate the power of lifting your home just a few inches above the earth. Because sometimes that's the difference between a house that collapses within years and one that quietly endures for 1,000. Part 3. The skeleton, separating the skin from the bone. Once the foundation was secured against the rot and the shifting earth, the Vikings made a decision so counterintuitive that it still puzzles modern builders. In a typical log cabin, the logic is simple. The walls hold up the roof. But in a Viking longhouse, the walls do almost nothing at all. The true strength of the building was hidden deep inside, in what archaeologists call the three-aisled system. Imagine stepping into a long, dimly lit hall and seeing 2 rows of towering wooden pillars stretching from one end to the other. Massive tree trunks, often carved from single oak or pine trees. These interior posts were the real load bearers. They carried the crushing tons of snow, the pounding of winter storms, and the full weight of the roof. And this choice unlocked a level of engineering brilliance that most people miss. Because once the roof was supported by this inner skeleton, the Vikings freed the outer walls from the burden of holding anything heavy. Suddenly, those walls didn't need brute strength. They could be optimized for something else entirely: breathability, climate control, and flexibility, the very traits that made the longhouse stormproof. Their wall system, called post and plank or stave construction, was deceptively simple. Vertical posts were slotted with grooves, cut not with modern saws but with axes and chisels. Into those grooves, the Vikings slid horizontal planks. Yet here is the key: the planks were not fastened. No nails, no rigid locks. Instead, they were allowed to float. To a modern carpenter, this looks unfinished, but to the Vikings, it was pure physics and pure wisdom. Wood breathes. It expands with moisture and contracts when dry. Nail it too tightly, and it splits when it shrinks or buckles when it swells. Give it space to move, however, and you create a living wall, one that adjusts naturally with the seasons. And when a storm slammed into the side of the house, that floating wall became a shock absorber. Instead of acting like a rigid drum, it shifted subtly, plank by plank, absorbing the wind's energy millimeter by millimeter. Nothing cracked, nothing tore. The house simply moved with the storm, the same way a Viking ship moved with the waves. This was not primitive construction. This was biomimicry, centuries before we had a word for it. A house designed to breathe, to bend, and to survive by separating the skin from the bone. Part 4. The Living Nail. Joinery without iron. Now we arrive at one of the most surprising truths of Viking engineering and the namesake of this very video. Why did these master builders create stormproof houses without a single iron nail? It certainly wasn't because they lacked the skill. The Vikings forged Ulfbert swords, blades so advanced that some metallurgists compare them to medieval supersteel. Their ships were held together with iron rivets that carried them across oceans. They understood metal better than any culture in the north. But they also understood something modern builders often overlook. Iron and moisture are a disastrous pair. In a damp longhouse, iron rusts. Rust expands. It splits beams from within. It invites rot. It becomes the weak link in a structure that must bend, flex, and breathe for centuries. So, instead of fighting the environment, the Vikings worked with it. They turned to a solution that seems humble, almost primitive, yet it is anything but. They used wooden pegs, tree nails, what we might call today the living nail. The brilliance lies in the science. These pegs were carved from hard, dense wood, like oak or juniper, then dried by the hearth until they were shrunken and bone dry. This shrinking was intentional. Once ready, the builders drilled matching holes through the beams they wanted to join, but not perfectly matching. They used a technique known as draw boring. The hole in the tenon, the wooden tongue, was offset ever so slightly from the hole in the mortise, the receiving slot. When the tapered peg was driven through, the misaligned holes were forced into perfect alignment. The joint tightened, as if drawn together by an invisible clamp, compressed with massive mechanical force. You could physically hear the beams lock into one another. And then nature completed the work. As the bone-dry peg absorbed moisture from the air, it began to swell. It expanded into every gap, every corner, every fibre of the beams around it. What started as a simple dowel became a living fastener, one that gripped harder with every humid storm and tightened itself every time the seasons changed. This was joinery not just engineered by human hands, but co-engineered by the climate itself. The wooden peg moved with the wood. It expanded when the beam expanded and shrank when the beam shrank. And unlike an iron nail, which stands rigid until it snaps, the living nail flexed with the house, aging with it, strengthening with time. This wasn't a compromise. It was symbiosis. A fastener perfectly matched to its material and perfectly suited for a home that was never meant to resist nature, but to dance with it. Part 5. Aerodynamics, the house shaped like a ship. If you study the ground plans of great Viking fortresses, places like Trelleborg or Aggersborg in Denmark, you'll notice something that stops you in your tracks. The longhouses are not rectangles. They refuse straight lines. Instead, they bow outward, the walls curving gently like the hull of a great ship flipped upside down. For decades, historians wondered why. Was this simply a stylistic choice? A cultural echo of their seafaring identity? A tribute to the vessels that carried them across half the world? But modern fluid dynamics finally cracked the code, and the answer is far more profound. This was aerodynamics. A flat wall, when struck by a powerful wind, becomes a bluff body. High pressure builds on the windward side, while a dangerous vacuum forms on the leeward side. That vacuum can rip shingles off a roof or tear the entire structure apart. It's the same force that can flip trucks on a highway or peel roofs off houses during storms. By curving the walls outward, the Vikings transformed their longhouses into airfoils, structures that allow wind to slide smoothly around their surfaces. The pressure difference drops dramatically. The wind has nothing to grab, nothing to pry loose, nothing to tear away. They didn't stop there. The gables, the roof's endpoints, were tapered like the prow of a ship, slicing the wind instead of fighting it. And the houses were deliberately oriented so that the prevailing winds struck the most aerodynamic angles, not the vulnerable ones. In other words, the Vikings built houses that sailed through storms the way their ships sailed through waves. They treated wind as an ocean, an invisible sea that demanded respect, technique and design, not defiance. At fortress sites like Trelleborg, this design is mathematically precise. Longhouses arranged in a perfect circle, each one slightly bowed to distribute wind load, each one positioned as though part of a giant engineered wheel. This wasn't rustic guesswork. This was geometry with military efficiency, architecture that rivals Rome in its sophistication. And what emerges is something breathtaking. The Viking longhouse wasn't just shelter. It was an aerodynamic bunker, sculpted to endure hurricane-force winds without a single nail. A structure designed not to stand against the storm, but to sail through it. Part 6. The Turf Revolution, Insulation and Camouflage. As the Vikings pushed westward, they encountered a new kind of harshness, not from wind or sea, but from the land itself. Iceland and Greenland were nothing like Norway. There were no grand oak forests, no towering pines to carve into beams. Instead, there was driftwood washed ashore, stunted birch clinging to volcanic rock, and endless stretches of grass waving in the cold wind. Most builders would have seen scarcity. The Vikings saw opportunity, and from that opportunity, they engineered one of the most remarkable dwellings in the ancient world, the turf house. This was not the crude mud hut people sometimes imagine. This was a deliberate, highly engineered structure built from the earth itself. The Vikings cut bricks of turf, called hnaus, from the bogs, selecting pieces where the root systems intertwined like natural rebar. The roots acted as a biological mesh, holding each brick together with surprising strength. They stacked these blocks in intricate interlocking patterns. One of the most impressive, the klombrunhaus, or herringbone pattern, angled the turf so each brick braced the next. The wall became a self-locking system, preventing the heavy earth from bulging or collapsing outward. Some walls grew more than a meter thick, massive, solid, and powerful. And inside those walls lived one of nature's most potent forces, thermal mass. In summer, the thick earth kept the interior cool, resisting the heat like a natural cave. In winter, it absorbed and stored warmth from the hearth fire and even from the bodies of the people and animals inside. Once heated, the turf walls released that warmth slowly, turning the home into a slow-burning heat battery that could endure brutal Arctic nights. But the roof, this was the masterpiece. The Vikings knew you couldn't simply stack dirt on wood. The moisture would rot the rafters within a season. So they created a brilliant composite. Wooden rafters first, then a continuous layer of birch bark laid like shingles. Birch bark is rich in oils and natural resins, especially betulin, that repel water and resist decay. This layer was their waterproof membrane centuries before modern roofing felt. Only after that did they pile the turf on top, and not just a little, tons of it. Enough mass to hold the roof down in hurricane-force winds, enough insulation to muffle storms into silence. Over time, the grass grown into that roof would knit together, transforming it into one single living blanket, hugging the structure beneath. And it had one more advantage, one the Vikings understood very well. From a distance, a turf house didn't look like a house at all. It looked like a hill, a swell of earth, a quiet bump in the landscape. In a world where raiding was a constant threat, invisibility was not optional. It was survival. The turf house wasn't just architecture, it was camouflage, it was insulation, it was a thermal engine, and it was proof that the Vikings didn't just endure the land, they learned to build with it, hide within it, and thrive because of it. Part 7. Fire, Smoke, and the Chemistry of Survival. Now let's step inside one of these Viking longhouses. Immediately you feel it. The darkness, the warmth, and the smoke, thick, drifting slowly toward the rafters like a living veil. At the center of the hall burns the Langeld, the long fire. There is no chimney, no brick flue, no modern ventilation system guiding the smoke upward. Instead, a single opening in the roof, or narrow vents at the gable ends called the vindauga, the wind eye, gently breathes it out. From that word, we get our modern window. At first, to a modern mind, this seems unbearable. A room full of smoke feels like a design flaw. But for the Vikings, smoke wasn't a nuisance. It was a tool, one of the most powerful tools in their architectural arsenal. As the smoke drifted upward, it coated the rafters in a thin, gradual layer of soot and tar. And with each passing season, that coating hardened. It waterproofed the beams. It discouraged insects. It arrested the growth of fungus. The long fire that warmed the Viking family was simultaneously curing the house itself, the same way smoke preserves meat. Their homes were being sealed, strengthened, and sterilized every single day. Yet smoke wasn't their only ally. The Vikings actively manipulated fire to protect their structures. Before posts were set into the earth, the builders lightly charred their outer surfaces, a technique we now associate with the Japanese sho sugi-ban. This shallow layer of charcoal became a natural armor. It repelled moisture, resisted decay, and made the wood unappetizing to pests. And of course, there was pine tar, one of the great secrets of northern engineering, created by slowly burning resin-rich pine roots in earthen pits. Pine tar was a thick, sticky, dark liquid that offered astonishing preservative power. When brushed onto house timbers or ship hulls, it formed a breathable barrier. Wood treated with tar could flex, expand, and contract without trapping moisture, all while repelling water with remarkable efficiency. If you visit a traditional Scandinavian stave church today, the smell that hits you, smoky, sweet, earthy, is the scent of Viking technology. It is the aroma of pine tar, of soot-hardened beams, of timber preserved through elemental chemistry rather than industrial coatings. Inside the longhouse, fire wasn't just warmth, it was medicine, it was waterproofing, it was pest control. It was the silent craftsman, working day and night, transforming raw timber into a structure capable of standing for centuries. The Vikings understood something profound. Survival is never just about resisting nature. Sometimes it is about collaborating with it, using smoke, flame, and chemistry to build a home that ages not toward weakness, but toward strength. Part 8. Wind management outside the walls. The Vikings understood that a house doesn't stand alone against the storm. The battlefield extends far beyond the front door, and so did their engineering. What they built outside the longhouse was just as critical as what they crafted within it. Archaeologists have uncovered curious low stone walls and turf mounds positioned a short distance from Viking homes, always on the side facing the prevailing winds. For years, these structures were dismissed as animal pens or storage boundaries. But when airflow scientists began modeling Viking settlements, a new and far more sophisticated picture emerged. These were not fences, they were windbreaks, engineered shields crafted with surprising nuance. Yet, unlike modern wind barriers, the Vikings didn't build massive solid walls designed to stop the wind outright. They understood, perhaps through centuries of observation, that a solid wall doesn't protect a home. It creates turbulence. The wind slams into the obstacle, curls around it, and forms chaotic spirals that can actually increase pressure on the building behind it. Instead, the Vikings constructed porous barriers, layers of stones, turf, brush, and woven branches. These structures didn't halt the wind, they tamed it. They disrupted its speed, fractured its momentum, and forced the remaining airflow to rise and glide over the Longhouse rather than crash into it. The result was a wind shadow, a pocket of calmer air hugging the home like a protective cloak. Wind chill dropped dramatically. The structural strain on the walls lessened, and most importantly, the Longhouse avoided the dangerous pressure reversals that could pull smoke back down into the living space, suffocating anyone inside. This wasn't random trial and error. This was microclimate engineering. The Vikings were shaping the wind itself, redirecting it, dissipating it, and transforming their environment from hostile to habitable. By the time you step back and look at an entire Viking settlement, its curved walls, its turf roofs, its floating planks, its living nails, and now its engineered windbreaks, you begin to see the truth. These weren't primitive homes. They were complete, integrated survival systems, tuned to the physics of a world that punished every mistake. The Vikings didn't just build houses, they built harmony with the wind. Conclusion: what we can learn. So in the end, what is the true lesson of the Viking Longhouse? Why did these structures endure for centuries while modern buildings, built with far stronger materials, sometimes fail within decades? The answer is disarmingly simple. The Viking Longhouse survived because it never tried to conquer its environment. It cooperated with it. Every force that seemed like an enemy, the moisture, the wind, the cold earth, became part of the design. The Vikings used the humidity in the air to tighten their wooden joints. They shaped their walls like the hull of a ship to let the wind flow around them instead of tearing them apart. They embraced the insulating power of the earth, using turf and thermal mass to stay warm through winters that could crush lesser homes. And this wasn't theory. We can still see the evidence today. At L'Anse aux Meadows in Canada, the turf outlines of Viking explorers have remained for 1,000 years, untouched by time. In Borg, the post holes of a massive chieftain's hall reveal a building that stood for centuries, long before concrete footings or steel reinforcements existed. But perhaps the most surprising lesson is that we are now returning to their ideas. Modern architects are rediscovering breathable walls, green roofs, and earthen insulation. They are learning, often reluctantly, that sometimes the most durable materials aren't the newest ones. Sometimes the answers were carved into wood and stacked into stone 1,000 years ago. Because resilience isn't the same as hardness. Resilience is the art of adaptation. It's the wisdom of building something that can bend without breaking, breathe without collapsing, and live in harmony with the forces around it. So the next time the wind howls outside your home and the beams creak softly, don't panic. That sound is a whisper from the past. It's your house doing exactly what the Vikings taught theirs to do. It's bending so it does not break. If you enjoyed this journey into the forgotten engineering of the North, make sure to like this video and subscribe to Historia Prime. There are countless secrets of the ancient world still waiting to be uncovered. Until next time, keep history alive.